Hi students, it is the second day of first lesson gravitation from science A. Within this part, we are going to discuss Newton's universal law of gravitation and how Newton has applied Kepler's law to prove his equation. See, what is meant by Newton's universal law of gravitation? It is also considered as a law of gravitation, not applicable for only Earth. It is applicable for all the objects in the universe, and so it is considered as a Newton's universal law of gravitation. What is the statement he has given? Every object in the universe attract every other objects. That means there is a force of attraction in between two objects or any two objects in the universe. And so he is stating like this: every object in the universe attracts every other objects with a definite force. And this force of attraction is directly proportional to the product of the masses of the two objects, and this force is inversely proportional to the square of the distance between these two objects. See, that means this law of gravitation or this gravitational force is dependent on two things or two aspects. The first is mass of the objects and second is distance of the object. See, how to discuss this one? First, we are going to discuss how the gravitational force that we are going to consider as a F. The gravitational force is F force. How it is dependent on mass? So first, we are not focusing on distance, only we are focusing on the masses of the two objects. See, this first circle or first part is the first object for us, and this is the second object. But when we consider the object, mass is concentrated at the center. So we are, for understanding, we are considering as a circular objects or a spherical objects. Spherical objects, mass is concentrated at its center. So when we consider distance in between two objects, from the center we should consider the distance. See, that is, this is the distance in between two objects. Suppose this is the length or distance in between that one. Why we should not consider this distance in between these two objects? See, we are considering mass, and mass, again I am explaining this one. Mass is concentrated at the center of the object, and so the distance is also considered from the center of the object. Spherical objects' mass is concentrated at the center. So by keeping the distance same, three possibilities we are considering here by taking different masses. So within these three cases, distance is same, and when distance is same, as we discussed, this force is dependent on mass and distance. As we are keeping the distance same, it will depend only on the masses. Consider the mass of first object is x and mass of second object is y. So according to the law of gravitation, the force in between these two objects is directly proportional to product of the masses of these two objects. So what is this one? The force is directly proportional to product of the masses. Mass of first object is x and mass of second object is y, and so it is x into y, that is x bar. So it is the relation between the force and the masses of the two objects. See, once again, we are not focusing here on the distance between two objects because in all the cases distance is same. Now, what is the second part? See, mass is x of the first object, but by keeping distance same, we are going to increase the mass of second object, that is double of the previous mass. So this mass is y, so here mass is 2y, twice the mass of the previous object. So definitely here is also, as the law is there, the force is directly proportional to product of the masses, and so this force is directly proportional to product of x and 2y, that is x into 2y, and that is force is directly proportional to 2xy. See, xy is the force in between two objects. Previously as a standard we have considered. So in keeping distance same and the mass of first object, if the mass is doubled of a second object, then definitely force also increases by 2 times. Mass increases by 2 times, force also increases by 2 times. Again, one is there. The first object is x here, as we have considered standard. So we are increasing this first object mass by 2x. That is twice of the previous mass. And here also the twice of the previous mass, that is 2y. So can we formulate here? This force is directly proportional to, by keeping the distance same, force is directly proportional to product of two masses, 2x into 2y. And finally we are getting 4xy. So xy is the mass, force in between the previous standard example. By increasing the mass of both objects twice than the previous mass, then definitely force increases by 4 times that force exists within the previous example. So it is an exceptional case, only concentrate on that one. If two objects are near to each other, having some distance in between them, then the force is directly proportional to product of these masses and inversely proportional to distance. In this part, we are not focusing on distance, only on the mass. So force is directly proportional to xy. So can we consider like this one? Force is equal to xy, and definitely here is also force is equal to 2xy, and here force is equal to 4xy. So what is our conclusion? By keeping the distance same, if mass increases 2 times of only one object out of 2, then force also increases by 2 times because it is directly proportional. And again, by increasing the masses of both the objects 2 times, 2 into 2, that is 4 times, force increases. Now focus on this part. Now we are keeping the mass same. Here we have focused only on mass. Here we are focusing on distance. See how it is dependent on distance. This is the first object. The object's mass is x, and this one is the second object. Mass is y. Here also we are considering this object's mass is y, and here mass is x. So when we focus on this one, definitely here masses are same. In the first example and second example, both objects mass is same. So force will not depend on mass here. Direct force will depend on mass. But as we are discussing, giving importance to distance, force will not work here. But now distance, see, this distance is only d. But here distance from the center is 2d. 2d means twice the previous distance. So what will happen here? See, here force is directly proportional to xy. Here is also force is directly proportional to xy because product of masses. So it will not play the role. But here force is inversely proportional to square of distance, that is d square. But here force is inversely proportional to square of distance, that is 2d square, because distance is 2d. So finally we are reaching 4d square. So here is also 1 upon d square, here is also 1 upon d square. But focus more here. Here it can be divided by 4. So as we are dividing by 4, definitely force decreases by 4 times. So see here, if distance is d, force is 1 upon d square. But finally we are reaching here, if distance increases 2 times, force decreases by 4 times. So what will be conclusion? Distance increases by 2 times, force decreases by 4 times by keeping mass same. Here we have discussed distance same, mass is different. Here mass is same, distance difference. If distance increases 2 times, force decreases by 4 times, that is 1 upon 4. If distance increases by 3 times, that is 3d. If it is 1 meter, then it is 3 meter, like this. So 3, so square of this 3, that is 1 upon 9 times. So if distance increases by 3 times, force decreases 9 times. If distance increases 4 times, then force decreases by 16 times, 4 square. If it is 5 times, definitely 25 times. So, as distance increases, force decreases. So, are you getting? Apple can be attracted towards the earth because distance is very less and moon is so far from the earth. So, as distance increases, definitely force decreases, and so earth is not able to pull the moon towards itself, but it can hold with that minor force. So finally we are reaching here by combining both the equation to form the equation or the formula for gravitational force. There are two objects which are distance d away from each other. For understanding, we are considering these two objects are spherical. The mass of first object is m1 and mass of second object is m2. That is, again, the distance in between them is d. But again consider this one. When objects are spherical, the force in between two objects is towards the line with joining the center of their mass, or joining the centers here, because these two objects are spherical. So definitely these two objects will attract each other towards their center. So this is the force. That is force F1, force F2, and both objects are exerting same force. So F1 is equal to F2. So just we are considering here only F. F is a force of gravity in between the two objects of mass m1 and m2, which are distance d away from each other. But see, when these objects are not spherical, then what to do? Then we have to find a, that is, center of its mass. How to find the center of mass? See, this one stick I am holding. If it is not a spherical, so how to find the center of mass? Hold this object like this one on your finger and try to balance it. See, it is balancing now. So this point above my finger is the center of mass of this stick. If it is a writing pad, so how to find a center of mass? Hold this writing pad on your finger at one exact one point. There is one point within this writing pad at which this is the point at which it gets balanced. So exactly the point above my finger is considered as a center of mass. And when any two objects are there, if you are going to join the center of mass of these two objects, spherical or irregular, then the line which indicating the two center of mass, the force is along that line. So for a good example, we are discussing objects spherical. So this is the force in between two objects. So according to Newton's law of gravity, this force is directly proportional to product of masses of two objects. So force is directly proportional to m1 and m2. Secondly, it is depend on inversely proportional to square of distance between them. So F is inversely proportional to d square. That means force is proportional to 1 upon d square. But distance and masses may be different, and so we have to join both these parts in one formula. So force is directly proportional to m1 and m2, that is product of two masses, and inversely proportional to d square. So can we consider this force is directly proportional to m1 m2 divided by d square. But proportion you want to convert into equal, then one constant we should take. See, why to take a constant? One good example I am explaining in front of you. There are two people or two persons working in the same company. One is a manager, second is a peon. The basic salary of peon and manager is like this one, 1000. It is the first case. And at that same time, the salary of manager was 10,000. There is a profit for company. Company decide to double the salary of each and every worker of that company. So double of 1,000, that is 2,000. So definitely manager salary also get doubled. So it is 20,000. Again next year there will be lot profit for the company. So again company has decided to increase the salary double of the existing one. So 2,000 changed into 4,000 and 20,000 changed into 40,000. So again what happened? The fourth condition. Now company has incurred loss. So company decided to decrease the salary by 10%, that is basic salary. So as minus, we should do minus basic salary, then we are getting 3,000. And here is also by reducing 10,000 we are getting 30,000. So what is going to happen with the peon? That is going to happen with the same happening with the manager. So as double, it is also the double. In which proportion there is a change in peon or manager, second person also get changed. So there is a direct proportion. If you reduce this direct proportion and directly taking equal to, so see what is the meaning? 1,000 is equal to 10,000. 2,000 is equal to 20,000. Is it possible? No, because we have changed proportionality into equality. So one concept we should discuss here. See, peon salary get divided by manager salary. So what is the thing we are getting here? We are getting here 1 upon 10. If you are writing here 1 upon 10, 1 upon 10, 1 upon 10 and 1 upon 10. Now see, 1,000, 2,000, 4,000, 3,000. So are we getting the same values or not? But here everywhere we have used the same thing, that is the constant value, and so this is considered a constant. Like this one, to convert the proportionality into equality, we have to take one constant. So proportionality gets changed into equality, and one new value we are getting here, and that is we have given name as G. So G, what is G? G is a constant, but we are using that for gravitation or gravity. So this is called as constant of or gravitational constant or constant of gravity. So finally we have reached the formula of gravitational force in between two objects. What is that? So gravitational force in between two objects is equal to constant of gravity or gravitational constant into mass of first object into mass of second object divided by mass square of distance between two objects. What is SI unit of gravitational force? Definitely, as it is force, SI unit of this gravitational force also Newton. Now, one important part we are focusing here, and that is what is the SI unit of constant of gravity and what is the formula for that. See, just we are starting here. Just we have considered one formula, and that formula is gravitational force is equal to G into m1 m2 divided by d square. If you want to form a formula for G, so remaining part get transferred. So what is this? G is equal to F. When M1 M2 it is for multiplication, so definitely it will go for division. One M1 M2 and here D square. So what is the formula for G? Formula for G is equal to force into distance square divided by mass of first object into mass of second object. See how to find out. There are two objects which values we can consider. See, distance we can judge. That means if distance is 1 meter, see, distance is 1 meter. Mass of first object, that is M1, is 1 kg. Mass of second object is also 1 kg. Then definitely there is a force or not. So gravitational constant SI unit of gravitational constant G is equal to force is measured into Newton, distance is measured into meter, and so d square, so it is meter square. So here mass is measured into kilogram. So kilogram into second mass object is also kilogram. So finally we are reaching Newton meter square divided by kilogram square. So if you want to change this index and you want to bring this kilogram to the numerator, we can do that one. So that is equal to Newton meter square kilogram raised to minus 2. Like this also we can do. Okay, pause. Now we are finding the value of G. What is the gravitational constant's value? See here, there are two objects. Mass of first object is 1 kg and mass of second is object also 1 kg. That is unit mass we are considering, unit mass. And the distance in between these two objects is 1 meter. So what is G? G is equal to F d square divided by M1 M2. Field is telling we don't having the force, that is F d we having 1, so square divided by 1 into 1, and finally we are getting G is equal to F. Then what is the value of G? G is force in between two objects which are of 1 kg each, and the distance between them is 1 meter. That means we are taking two objects of 1 kg. By keeping the distance away from them, each other is 1 meter, and we have to calculate the force. And that force is gravitational constants. The first time in the history, one person has calculated that force in between these two, and that person's name is Henry Cavendish. Henry Cavendish experimentally he has found the value of G, and the force in between these two objects in such a condition is 6.673 into 10 raised to negative 11 Newton meter square per kilogram square. So that is the finally we are reaching towards the value of G.